Hello class, welcome to our lesson today, the second half of section 6.6, which deals with normal distributions as an approximation to binomial distributions. These two slides are just a review of what we talked about the other day. Remember that the requirements have to be satisfied for being able to use the normal approximation. So n times p and n times q have to be greater than or equal to 5. And then we can use the formulas below to find the mean and standard deviation. So to find the mean, it's just n times p, which is expected value. And then n times p times q square rooted would be the standard deviation. That's the same mean and standard deviations from chapter 5 when we dealt with binomial ideas. And then we'll use those to deal with the normal approximations. The other thing you have to remember is the continuity correction. Now, students sometimes get themselves a little confused on this. You only have to do this if it's a binomial case, which is an n and then probability of success type of idea, because that's a discrete variable, whereas the normal distribution is on a continuous scale. The one in your textbook uses different numbers, so you might want to look at that one as an extra reference. But remember, if it's at least something, you want to include that, so you have to move backwards a little bit to 7.5, and then it's everything and above if it was at least 8. If you wanted more than 8, you'd have to go further past 8, so you want to go to 8.5 and then higher. At most 8 would be everything from 8 and below, but including 8. So if this is where 8 is, you have to go further to the right to include it, which would be 8.5. Fewer than 8 would mean not include 8, so you go down to 7.5. And exactly 8, even though it requires 2 z-scores, is sometimes the easiest for students because you just go half in both directions and have 2 z-scores. You'll want to make sure that you're looking at that for this week's assignments and for your upcoming tests. Okay, you don't want to miss a lot of points because you forget to do the continuity correction. On the flip side, other questions like what we did before, where we gave you the mean and standard deviation, and it wasn't a binomial case, it was on a continuous scale already, so we didn't have to worry about dealing with this continuity correction in those cases. So you want to make sure you're paying attention to when you should use it, when should you not use it. Typically, if they don't give you the mean right now, which means you have to find it using n times p, that's the giveaway. You have to do the continuity correction. Okay, this question is dealing with the yellow and green pea pods. 25% are yellow, 75% are green. An experiment of 600 pods, so that's n. Okay, so n would be 600. He found that 160 pods were yellow. Okay, find the probability that at least 152 are yellow. Now, this information about 160 is actually not that useful. Okay, we have to use the probability that is assumed or implied, which would be 25% is P, and then 75% is Q. So the mean would be N times P, which would be 600 times 25%, which would be 150. N times P times Q square rooted would be the standard deviation of 10.61. If you have to find those ideas, that's a giveaway that you probably want to use this continuity correction. Now, we asked these similar questions in Chapter 5. The problem with Chapter 5 is I could only ask certain styles of questions because the numbers would get too large too quickly. And so when we're looking at these situations, okay, the reason the continuity correction is useful is because it allows us to do large data sets very quickly, whereas the other formulas that we looked at in Chapter 5 sometimes are a little bit more cumbersome and tedious. We want to have at least 152 yellow pods. So here's 152. And again, my picture's just roughly drawn. I'm not saying that this is exactly where it would be, but at least we get the idea. So here's 152. I want at least that's area to the right, but I want to include it. So I need to work backwards a half to 151.5, and then that would be the area to the right. So my x value then would be 151.5 minus the mean of 150 divided by the standard deviation of 10.61. Once I've done that, then my z-score value is just 0.04 or 0.14. And my z-score then would be anything greater than that. And so I find the z-score of 0.1, or the probability, of the z-score of 0.14, and that's 0.5557. But then again, I have to do 1 minus that to work backwards in order to figure out the probability that it's at least 152. So you had to do the continuity correction here because it was a binomial idea, approximating as a normal distribution. And then we use P, Q, and N to find the mean and standard deviation. This next question, find the probability that exactly 160 are yellow. Now this should be fairly unlikely because anything that's exactly something is going to be very unlikely to occur. In this case, since it's exactly, I have to do 2 z-scores. So I do 159.9 minus the mean divided by standard deviation. 160.5 minus 150 divided by the standard deviation. I should get two z-scores that are fairly close to each other, so z equals 0.90 and z equals 0.99. Remember, you're going to round those always to two decimal places as you go through these scenarios. And so I'm looking for the probability it's between those two, okay? Some of you on your last test were having trouble writing some things. You were trying to claim the z-score equals the probability. These two things are not the same. One is the z-score, which is the standard deviations above or below average. And then this is the probability of that occurring, or area to the left underneath the curve. When I subtract these two areas that I get from my table, I get 0.023. One other thing is many of you have been using the table from the book, which is what I would expect you to do. If you use a different table, they may go to 5 places, for example, and that might cause a problem on some of your answers compared to what I am expecting you to find. So you want to make sure you use either the PDF one that I sent earlier in the semester, or at least the one from the textbook. That would be the suggestion as you're going through those questions. Remember, you have to do the continuity correction. Anytime you have to find the mean and standard deviation because it's a binomial distribution. And the reason we have to do that is because the z-score idea is always from a continuous scale, and the distributions of a binomial are from a discrete scale. And so we have to adjust for that, and we always have to deal with that plus or minus a half. It's a matter of which way do you go, though. So make sure, do you want to include it or not, and then move the needle kind of one way or the other, depending on the situation that you're looking for. Have a good day, everyone.